This isn't just one traffic sign, it's hundreds of them. And all of this with just one click. Hi, I'm Dave the Blender, and today I will show you the potential of procedural design in Blender. We'll divide this project into two parts. First, we'll create procedural traffic signs using geometry nodes. Then, we'll build a UI with Python to make it easier to use. If you are interested in procedural modeling or technical art, this video is for you. The first thing we're going to do is build the core logic of the mesh. To do this, I'm gonna create a geometry nodes modifier and call this node group SignEngine. Now, we don't need this input geometry because we will be using curve circle. So just like this, we can control the shape of it. So I can change it to draw some polygons, and I can also change the shape or the size of it, both. Now, let's bring a transform geometry node. So I can control the rotation in Z. Rotation. And this is gonna be type angle. So now I can turn it. Good. Now, to add a little bit more of realism, I can just add this fillet curve node. So I make the edges a bit smooth. Let's add 5 and 5 centimeters, and now this is what I want. However, I want the user to be able to control this, and for this we will use a switch to activate and deactivate this. So just like this, group input. And let's also bring this here so I can control these parameters. Now we can call this fillet count and radius. And we can also change the value to a single, since it's just one value. And now we can activate it and deactivate it. All right, this is the first part of our logic. We can just group this and call it base shape. And we can move on to the next part. So now we will fill and extrude our mesh. So we have a 3D mesh right now, and this value would be the thickness of our sign. So we can just plug it here and call it thickness. Again, just single value. Now we are missing, let's change this to endgones, and now we are missing this face down here. And we can just solve this by joining the extruded mesh with this mesh we had before, just like this. However, if we check the face orientation, we realize this face needs to be flipped. So we can just do it with the flip faces node, and like this is fine. To avoid duplicated vertex, we can just use the merge by distance. And now we have a pretty good basic shape. What I want to do now is to extrude a border here. And to do that, what I would need to do is to extrude this mesh again, but I only want to extrude the down face, the face that's pointing down. So for this, I will need to filter the geometry by normal, and that part of the geometry that has a normal equals to -1, compare equal not X, but Z to -1. That's the one we want to extrude. So if we want the upper one, we just need to change this to 1. That's gonna be the other one, but the normal pointing downwards is it identified by -1, the value -1 in Z. Now, what we want to do actually is not extrude this yet. So let's pull it to 0. Let's change this view so you see it more clear. We just added a new face here that I'm gonna scale now. Scale only the top. And if I scale this, you will see I've added that part of the geometry. Now this is gonna be my border, and that's the part I'm gonna extrude using this side socket here. So let's just put this to 0.9, and let's extrude only this side here by this. Now you see I have kind of a border now. So you can just come here and add our border length. Good. However, this thickness of the border changes with the radius of our shape. So the bigger it goes, the bigger it turns. I would like to control this thickness. So this thickness is the same as the thickness we defined previously, independent of the size of the sign. Now, to do this, we need to understand how these polygons work. Our sign is built using a polygon with a certain number of sides, 5 in this case, and a smaller version of it inside. This part here represents the thickness. This thickness is the difference between these two lines here. These lines are called the apothem, and we will calculate their value based on the radius and the angle. If we apply basic trigonometry here, this is the result we obtain. Going back to our shape, the thickness is equal to the larger apothem minus the smaller one, and the smaller one is the result of multiplying the larger one by the scale factor. With all this information, this is our scale factor for a constant thickness. Okay, now that we have understood how this works, let's just move this here, and let's calculate the scale factor. Group input. Now, let's divide 180 by the resolution to radians, since Blender does not understand degrees. Cosine of this, multiply by the radius. Correct. Now we just need to divide thickness. Here we have it. And 1 minus this value. This is my scale factor. Now I can just plug this here. And in the moment I plug it, this thickness remains as this thickness here. So I can change it. And if I change the size, it remains constant. Now, what we can do is make a group here. Let's change this to S, scale factor, and radius, and thickness. And this is going to be a converter, and that's what we have now. So we can use it in the future. Now, this is the second part of our geometry. We can just frame it, call it thickness and border length. And what we are gonna do now is something similar to this part, but we are just gonna do a frame here for some signs that needs a frame around, and we will just follow the same logic as here.
So we will extrude the mesh, but only the face pointing upwards. So now it's normal. We'll compare it. To 1, positive 1. And that's gonna be our upper face. Now, same as before, this is 0. We will just scale that face, or scale the top like this so we can see it. Again, it's the same. Now the scale factor, let's use again the scale calculator. Scale, we don't have it here. We didn't call it scale calculator. Just here, and the values. Input, resolution, radius, and the thickness. For the value of the thickness, we will use another one that I will call frame, and this will be the length here of the frame. So we can also have some control. Frame. And now we can control the frame. Now we only need to extrude that part, so the one on the side, and the value, the offset I want to apply is the value of the thickness, so something like this. All right, so let's just clean things up here. The thickness, something like this. Border length 20 centimeters. So let's bring this down, and the frame something like this. This is starting to look like a sign. All right, let's just frame this again and call it frame. Now I also want the possibility to have no frame here. For this, we will use switch node again with geometry. So true here, false would be just value without frame. And for the switch, we will be using the frame size. So if this frame is bigger than 0, then we will have a frame. But if we just put this to 0, there is no mesh calculation done. All right, let's keep going. Now what we will do is add some text. So we have this string to curves node, and we can just apply some text with it. We will need this for some speed signs in which we will have to draw some numbers, for example. So let's just bring the text and the size of the text here. And we will just apply switch node again, in case we don't want any of these numbers or of the text displayed. So we will just have the sign we calculated before joined with the text if we have this active, otherwise we will not have it. Now for the text, let's just activate it so far. Let's just write something like 100. We see we have 100 there. Let's just put this to something like 36. We have a round one without that. And change to this. Now here we will change this to center, middle, and midpoint, so it's completely centered. And what we need to do now is bring this bit up, because we have the thickness lying. So this 100 is not actually, it's on the 0 on Z. We need to bring it a bit up so we can see it. For this, we will just apply a combine here, and we'll plug the thickness here. Now it's on the surface. Let's just make some room. And now that's just a curve. We'll need to fill it with endgones and extrude it. And I'm going to extrude it the value of the thickness. Exactly. Let's break the input group here, and let's control if we want to have text or not. Now, text, let's bring it up. Let's just call this with text, text and text size. You can just hide the unconnected sockets, since that input group is getting bigger. Now let's frame it and call it text. Now if we add some kind of frame here, this already starts looking like a traffic sign. For the last part of our SignEngine, we will just add the logic for some shapes we can add to our signs. So for this, we can start with some quadrilateral. Let's just join it to our sign. And again, I'm using the switch solution for activating and deactivating this thing. Now, let's just create the shape of the no entry sign. For this, I will just bring the group input, and I'll multiply the radius for 1.5, and same 0.4. And like this, I can have something like this. As you see, we still have to bring it to the set level as we did before with the text. That's just by moving it up the value of the thickness in set, just like this. And now we fill, it's the same logic as for the text. We fill it and we will extrude it. Again, we can extrude it the value of the thickness. Just something like this. Okay, so what we can do here is just, we can take all of this, just make a group. I'll call this group shapes. This is maybe a geometry type. And here we will have the radius, thickness, now let's organize this a little bit. So what we have here is one of our shapes, because here we can create more. Let's just do it like this. We frame it, no entry, and then this is just positioning and thickness. Now we can create a menu, switch menu here. This is gonna be A, comes here, and then we can just go to node, delete this one because we only have one so far, but we can add more in the future. No entry, and just bring this one here. This goes to the top, and we can call it shape type. So here shape type, and we also bring this one to the switch so we can control if we want to add some shapes or not, just like this. All right, so far we only have one, but we can add more in that group afterwards. Now this is gonna be shapes. So to have everything a bit more clean, what I will do here is just moving everything up the value of the border length. So the sign starts at z equals 0. So just to do this, we need again a transform geometry node, group input, combine, and thickness z, and we just put it here. So just like this, we have our sign engine ready.
As you can see, the possibilities here are endless. In the next video, we will see how to build the next layers of the mesh logic.